All right, so here we go with the review sheet here. So on part of your test, you will have to do it without a calculator. And so we're going to do this whole front page without a calculator. And so I'll show you like what you'd be required to know or do. These parts in gray, you can do them algebraically, and then if you need to, you would put them in a calculator. So the part that you can get to without a calculator, that's what you would be required to be able to do. Anyway, here we go. So when I look at the first problem, this is an exponential function. It is a decay function because of this 1/4 right here. The base is less than 1, and it has been moved to the left 3 and up 1. So, know those transformations and that it's a decay and that type of thing. So, normally an exponential function has a horizontal asymptote of y equals 0. So in this case, it's going to be y equals 1, because when you move something up 1, that changes the horizontal asymptote. So I don't have it down here, but anyway. All right, so you can kind of, like that little pivot point that you have, the point used to be at 0, 1 on a exponential function, but that point gets moved to the left 3 and also up 1, so it's right here. All right, so let me see, 1, 2, 3, up. There it is. And it is going to be a decay, so it is going to travel down, but I will wait until we get the y-intercept for that. All right, so my domain is anything. Anything can be x, so all real numbers, -infinity to infinity. My range is everything above 1, so from 1 to infinity. Okay, my x-intercept, I can see that my x-intercept is no x-intercept, but my y-intercept, I can see I do have a y-intercept. So to do the y-intercept, I can go ahead and plug in 0 for x. So we'd have 1/4 to the 3rd power, because 0 plus 3 is 3, and then plus 1. So 1/4 to the 3rd, so that would be 1/64 plus 1. So it would be 65/64, right? So my y-intercept would be 0 and 65/64, because that's 1 and 1/64. All right, so then I would obviously need to go to a calculator to see what decimal 65/64 was, but I can tell that's a little bit above 1, so I'm just going to go ahead and put it right there. All right, so the rest of this goes there, and we should be able to at least get the general shape of the graph. All right. All right, so here we go. Asymptote. Oh, I did have a spot for the asymptote there. So asymptote is at y equals 1. It's continuous everywhere. There's no x values where it's not continuous, so it's continuous from -infinity to an infinity. Let's see, this graph right here is decreasing. So, because it's decay, so it's not increasing at all, it's decreasing everywhere. And that is it. All right, over here, we have an exponential function again, but this time my base is the e, so it's 2.7, right? So it is a growth problem, but it has been reflected. So it's growth, it's been a reflection, reflection over the x-axis, and it's been moved down 3. So that down 3 makes my asymptote be y equals -3. So I'm going to go ahead and draw that on here. And let's see. So this thing has been moved down 3 and reflected, so it's upside down. It was a growth, so it was, kind of going like this here, but it has been flipped over, so it is going down like this. So I think I'll wait for my y-intercept, but that's the general shape. Again, looks like right there I do not have an x-intercept. Now, one reason that I do not have an x-intercept is also this. When I do an x-intercept, I plug in 0 for y. So let's try to do that, just to prove it to you. So I plug in 0 equals -e to the x minus 3. So I move 3 to the other side, so 3 equals -e to the x. And then I move the negative, so I divide by -1, so -3 equals e to the x. So think about solving this. If I was going to solve this, I would have to take the log of both sides to get this to cancel and get myself to get an x. Well, I can't do the ln of -3. And also, e to a power is never going to have a negative answer. So that's also another reason why this does not have an x-intercept. If it did work, then that's how you would get the x-intercept, but it does not. All right, the y-intercept. The y-intercept was an x equals 0, so I have negative e to the 0, so it'd be negative 1 minus 3, so it'd be negative 4, so 0, negative 4. So there it is right there, and we can kind of know that it's going across here. All right, so domain is negative infinity to infinity. My range is from negative infinity up to negative 3, not including 3. It's continuous everywhere. The increasing interval is nothing because this whole thing is decreasing from negative infinity to infinity. All right, the next one, my log function. So my domain and my asymptote pretty much go hand in hand. This right here controls the domain and the asymptote. So the domain is that 2x plus 5 has to be greater than 0. It can't be equal to 0 because you can't do the log of 0. It can't be negative because you can't do the log of a negative. So you set up yourself with a little inequality here. So take away 5 and divide by 2. So basically it's negative 2.5. So my asymptote is at negative 2.5. My domain is from negative 2.5, comma, over. All right, so let's see. Negative 2.5, so right about here. Okay, log functions are going to be to the right of that normally because it hasn't been reflected or anything. So I will have an x and a y-intercept, so I will wait for that in a second. And so I have negative infinity to infinity for my range. It's continuous everywhere from negative 2.5 over. And the whole time it's going to be, the log functions is going to come up like that. It's going to be increasing the whole time that it's in existence. So it's increasing from negative 2.5 on, and it's not decreasing at all. All right, so let's work on our x-intercept and our y-intercept. Okay, so my x-intercept, I let the y value be 0. So I'll do that right up here, my x-intercept. I let y be 0. So I get 0 equals log, there is no base, so it's base 10, of 2x plus 5 plus 1. All right, so take away 1. So minus 1 equals log base 10 of 2x plus 5. Well, write this as an exponent, 10 to the negative 1. Well, that's 1/10, because 1 over 10 to the first, so 1/10. So I'll say 0.1 equals 2x plus 5. So all I have to do is solve that equation. Take away 5, so 0.1 minus 5 would be negative 4.9 equals 2x. So x is negative 4.9 over 2. So, 49 divided by 2, let's see, 48 divided by 2 is 24. So 49 divided by 2 is 24.5. And this would be 1 decimal over, so that would be 2.45 negative. Okay, so my x-intercept is negative 2.45 and 0. So negative 2.45, like right before 2.5. My y-intercept is when x equals 0. So my y-intercept, when x equals 0, so it would be the y equals log, this part would be 0, so it would be log of 5 plus 1. So I would have to go to the calculator for that, but you could tell me that it was log of 5 plus 1, and then if you needed to, you could go in the calculator, you could calculate that to be 1.7, 0 and 1.7. But this expression right here would be the equivalent of your y-intercept, log base 5 of plus 1, log base 10 of 5 plus 1. All right, so let's see, that was 1.7. All right, so we go ahead and draw it. All right, on to the last one here. ln of 4x, remember ln is log base e, right? So let's see, it's been moved down 2. It hasn't been moved left or right at all. So my asymptote is still at x equals 0. All right, so domain, everything to the right of 0 so 0 to infinity. My range is everywhere. Okay, and let's see, my x-intercept. X-intercept is when y equals 0. So 0 equals ln of 4x minus 2. Add 2 to both sides. So remember, ln is log base e. So I'd have e to the 2 equals 4x. So my x value would be e to the 2 over 4. Well, so again, you could tell me that it was e to the 2 over 4, and then if you needed the actual decimal, you could say that e to the 2 over 4, you could go in and it's 1.8 is what it really is. So 1.8 and 0. So there it is, right there. All right, the y-intercept is when x equals 0. Well, turns out if I put x equals 0, I'd have ln of 0 and then minus 1. Well, I can't do the ln of 0, so there is no y-intercept. Okay, so this kind of creeps up there and goes back down towards the asymptote. All right, so on number 5, you should be able to do things like these without a calculator. So log base 7 is 7. So 7 to the first power is 7 again. Remember, this is a 10 right here. 10 to what power is 0? Well, 10 to no power is 0, so can't be done. Here, 4 log base 4 kind of cancels out, you could say, and you get 9 to drop down. Here, ln e cancels out to a 1, basically. So you would get 3 times negative 7, so you get negative 21 here. 3 to what power is 81? 3 to the 4th. X to what power is x again? 1. 4 to what power is 1/64? Well, negative 3. Here, now, I would say that e and ln cancel out, and oh, the answer is negative 2. But you cannot do that when this part doesn't exist to begin with. You can't do the log of a negative number, so you cannot do this problem. Here, 5 to what power is 1? 5 to the 0 is 1. Base 10, 10 to what power is negative 25? No such thing. ln of e, 1, because you're saying e to what power is e again. Here, e and ln drop out, so 8. E to what power is 1 over e to the 5th? Well, e to the negative 5. 27 to what power is radical 3? So I would rewrite this as 27 to what power equals radical 3. Well, square root of 3 is 3 to the 1/2. So I would know that 27 is 3 to the 3rd. And then I have what power here? So I would say 3 times something has to be 1/2. So that would be a 6th, right? 3 times what equals 1/2? Because I'm looking at this piece right here. I'm looking at this little piece right here, equaling that little piece right there. So 3 times what equals 1/2? Well, 3 times 1/6 is 1/2. So my answer is 1/6. All right, here, 10 to what power is negative 100? No such thing. 3 to what power is square root of 3? So 3 to the 1/2 is square root of 3. All right, so next part here. So here we are condensing. So we do condensing more than we do expanding, like in number 7, but let's see, I can put 12 up here as an exponent. I can put 5 as an exponent, and the last one doesn't. All right, so I have 1 log base 5, x 12 is divided by x to the 5th, and it's multiplied by 3. So I'm going to put that multiplication of 3 up here. So I basically get log to the 5th, or log base 5, sorry, and the x12 and the x5, those can reduce to x to the 7th. So I have 3x to the 7th. And you could have noticed that right here. You had 12 log of x minus, what was it, 5 log of x? So you could have said 7 log of x right away, all right? But either way, you get the same result. Right over here, I got 3 up there, got 4 squared up here, and a 1/3 power, you can write it as a 1/3, or you could write a cube root. So I have 1 log, let's see, 4 squared, that's 16. So I'm going to put 16 x to the 3rd. These are all multiplied. And then I have 5x plus 2 to the 1/3. Again, you could write cube root. Alrighty, so expand these. So I notice in this problem, I have one part, another part, and a final part here. Okay, I notice never mind. All right, I was going to do the next one, but that's okay. So I have log base 4 of 4. It's multiplied by x to the 3rd, so it'll be plus log base 4 of x, but the 3rd power can come out front, and divided by, so minus log base 4 of y, but the 5 can come out front. All right, in letter B, I notice that I have two pieces. So I have one on top and one on the bottom. Okay, remember, fourth root is a fourth power. So I have ln of e to the third, well, the 3 can come out here, minus ln of 5x minus 2 to the 1/4, but the 1/4 can be out front. Also, one more thing, ln of e, they knock each other out. So my final answer is 3 minus 1/4 ln of 5x minus 2. And you are done. You cannot break up the 5x minus 2, remember. All right, in this last problem here, I have one piece on top. I have one piece here and one piece there. Two things on bottom. So I have log base 7 of x plus 4 squared, so that 2 can go up front. The next two pieces are both divided, so they will be minus log base 7 of 5 and minus log base 7 of x squared, but the 2 can go in front. Now the only thing I would say, if this can be done, but 7 to what power makes 5? Who knows? So you're finished. But if it was something you knew how to do, then you should answer it. All right, now we got some equations to solve. Excuse me. So letter A I can do by just equating the bases. 25 is really 5 squared, and then I have 3x plus 2. 125 is 5 to the third, and then I have a 4x. So I can see here that 2 times 3x plus 2 has to equal 3 times 4x. So I can just drop the 5 business and just say 2 times 3x plus 2, so 6x plus 4 has to equal 12x. So I get 6x over here equals 4, so x is 4 over 6, or 2/3. Now with exponential equations, you don't really have to check for extraneous solutions there because anything is okay. All right, over here I add 2 to both sides. So 3 to the x plus 4 equals 12. Well, no power of 3 that I know makes 12, so we're just going to go ahead and do log of both sides. Or you could write it as a log if you prefer. So the x plus 4 is allowed out here now, and I have ln 3 next to it equals ln 12. So I will divide out the ln 3, so x plus 4 is alone now. It equals ln 12 over ln 3, and I just have to take away 4. So if I was doing this without a calculator, I would say ln 12 divided by ln 3, and then minus 4. But if you put that in your calculator, you get approximately negative 1.74. All right, letter C. So I can't do anything on the left-hand side. I'm going to bring the 15 over. So e to the 2x minus 2 e to the x minus 15. So remember, you have to see this as this. You have to see e to the x squared minus 2 e to the x minus 15. So what you're really seeing is like y squared minus 2y minus 15. So you're really factoring this. So you're factoring what makes 15, but also the 2. So y minus 5 and y plus 3, right? And so what you do is you put your e to the x back in. So these two lines right here are just for you kind of like figuring out what's going on and then what you're factoring to, and then you go back and you put your e to the x. So this is really e to the x minus 5 and e to the x plus 3 equals 0. Well, if I go ahead and continue solving those, I'll do that right here. So e to the x minus 5 equals 0. That means e to the x has to equal 5. So do the log of both sides, and I get x equals ln 5. Well, when I do e to the x plus 3 equals 0, I get e to the x equals negative 3. Well, e to the x can't be a negative number, so this part's no solution. So my only answer is ln 5. All right, for letter D. I see some logs and I see some numbers, so I'm going to get these logs together. So I'm going to put this guy on the other side. So I have 2 equals log base 6 of x plus log base 6 of x minus 5. Okay, so addition turns into multiplication, so I have log base 6 of x times x minus 5 equals 2. So now I write it as an exponent. So 6 to the 2, that means 36, equals x times x minus 5. So that would be x squared minus 5x, let's bring the 36, equals 0. Okay, factor that into x minus 9 and x plus 4. And my two answers then would be that x equals 9 and negative 4. But I go back and check, and I do notice that if I put a negative 4 right here, that would be bad. It would also be bad right here. But positive 9 would be perfectly fine. So negative 4 is extraneous. My only answer is 9. All right, on letter E. Again, logs with a number and then two logs. I'm going to bring the logs together. So I'm going to have log base 5 of x squared over 8 minus log base 5 of x over 40. This all equals 3. So remember, subtraction is division. So if you can look ahead, I'm going to be dividing these two pieces. So I'm going to be dividing x squared over 8 divided by x over 40. So let's work that out a little bit. So x squared over 8 divided by x over 40. Well, that means x squared over 8 times 40 over x. So this is going to be 5, and this is going to cancel out to an x. So this is going to be 5x, okay? So log base 5 of 5x equals 3. All right, so I have 5 to the third, that's 125 equals 5x. So x must be 25. And that's perfectly fine to put 25 back here or here, so that is my answer. All right, so next one, I have all logs, so let's combine these things. So this would be log of x to the third over 5. Over here, this is log of x to the third plus 7. Okay, so x to the third plus 7 has to equal x to the third over 5. Let's multiply by 5, so I get 5x to the third plus 35 equals x to the third. So let's take away an x to the third. So I have 4x to the third plus 35 equals 0. Well, this is just a normal equation to solve. So x to the third equals, I'm going to have to take away 35 and divide by 4. So it'd be negative 35 over 4. So I would go to my calculator to see what this was, but then remember I would just apply a cube root. So my answer, I can do it without a calculator, is the cube root of negative 35 over 4. So if I had to ask you that, then that would be that. But if I had a calculator available, my answer would be about, I don't have it worked out, and you know why? Because the cube root of a negative is a negative. And so I don't have it worked out on my paper, because if you look back here, you can't put a negative there. So that means that this answer that we're about to get was actually going to be no good. So no solution. There you go. No answer. All right, this last problem here also has all logs, so I'm going to condense it. So let's see, I'm going to be multiplying ln of 2x times 4 minus 16 over x equals ln of x minus 2 squared. So basically I can drop the ln's now. 2x times 4, that'd be 8x, minus 2x times 16 over x, so it's going to be 32, equals here x minus 2 squared. I'll just leave it there for now. All right, so let's work this out. X minus 2 squared, I get x squared. And then remember, I multiply these three things together, so I get 4x, but it's negative. I square the 2, so plus 4. All right, has x squared. I'm going to get everything on one side and factor. So x squared is going to be minus 12x, add 32, so plus 36. Okie doke. So when I factor, it's x minus 6 both times. So my answer is 6, but I check that out. Can I accept a 6 here? It's 2 times 6. 16 over 6, let's see, 16 over 6 is going to be less than 4, so 4 minus 16 over 6 will be positive. 6 minus 2, 4, that's fine. So we're good to go. All right, so also don't forget, we reviewed them in class on Wednesday and Thursday, but you got some formulas here. We reviewed using this guy right here, but you know, like this one here, just plugging in some numbers, so plugging in numbers here. This is the one you really got to worry about, but we review those over what you did in section 3.1, how to find your rate of growth or decay. That's the hard part first, but then after that, it's just usually plugging in numbers. Okay,